Did a piece of another solar system just send us a message written in metal? In the vast, cold emptiness of space, a traveler from a distant star system recently made a close pass by Mars. Astronomers have named this object 3I/Atlas, with the I marking it as an interstellar visitor, only the third of its kind ever confirmed. As it journeyed through our cosmic neighborhood, telescopes on Earth and around Earth trained their lenses on it, eager to learn its secrets. What they found was both subtle and surprising. Hidden within the faint light reflected from this alien object were unexpected signatures, faint whispers of iron, faint whispers of nickel that are not typically seen in common comets from our own system. To understand how scientists found metal in an object millions of kilometers away, we must look at the language of light. When 3I/Atlas passed near Mars, powerful ground-based telescopes like the Very Large Telescope in Chile and space-based observatories like the Hubble Space Telescope were tasked with capturing its faint glow. They did not just take a picture, they performed spectroscopy. This technique works like a prism, splitting the incoming light into a rainbow or a spectrum. Within that spectrum, dark or bright lines appear at specific wavelengths. Each element and compound has a unique barcode of these spectral lines, allowing astronomers to read chemical makeup of stars, galaxies, passing comets. The data returned from 3I/Atlas was intriguing. Within its spectrum, astronomers identified faint but distinct emission lines that correspond to vaporized iron and nickel. Specifically, the measurements pointed to a cloud of neutral metal atoms in the object's coma, the hazy atmosphere around its solid nucleus. These are not elements one expects to see glowing so prominently in a cold object far from the sun. Multiple observation sessions produced consistent data, strengthening that this was not a temporary or erroneous signal. The presence of these metals as a gas means something is liberating them from the surface and energizing them to glow. What does a metal signature like this actually mean? Astronomers have proposed three main possibilities. First, 3I/Atlas might be far richer in rocky metallic materials than Oort cloud comets. Even weak solar radiation at Mars's distance could heat the surface and cause volatile metals to sublimate into gas. That would create the metallic cloud telescopes detected, suggesting 3I/Atlas might be a dusty metallic rock with some ice. Second, the object's high velocity and dust behavior. Interstellar objects move at incredible speeds. As 3I/Atlas shed dust, tiny grains could be superheated by solar radiation or collide with solar wind so violently they vaporized instantly. If the dust was rich in metallic silicates, this could release puffs of iron and nickel atoms detectable from Earth. This theory emphasizes dynamic, high-speed processes in the object's environment rather than the main body's composition. Because 3I/Atlas originated from another star system, it may have been formed under conditions vastly different from our own. Perhaps it was born in a system with a much higher abundance of heavy elements, making metallic bodies more common. Alternatively, it could be a fragment of a much larger parent body that was shattered in a cataclysmic collision long ago. Such an impact could have exposed a metal-rich core or created fragments with unusual chemical makeups. Of these three possibilities, the most likely scenario is a combination. A hybrid object between comet and asteroid, with high-speed exacerbating metallic vapor release. The significance of 3I/Atlas and its metallic signature extends far beyond a single curious object. Each interstellar visitor provides us with a rare and precious sample of material forged in another solar system. By studying its composition, we can begin to answer fundamental questions. Are the building blocks of planets distributed the same way around other stars as around our sun? Or does each star system follow its own unique recipe? The iron and nickel found in 3I/Atlas suggest materials available for planet formation elsewhere might be different or mixed in different proportions than what we are used to. This discovery serves as a crucial test for our scientific models of planet and comet formation. Our current models are based almost exclusively on what we can observe within our own solar system. We have theories of how dust and gas come together to form everything from tiny pebbles to planetesimals and gas giants. It is also important to be very clear about what this discovery does not mean. The detection of metallic signatures is not evidence of extraterrestrial technology. Iron and nickel are forged in massive stars, and natural processes can incorporate them into comets and asteroids. In summary, the interstellar object 3I/Atlas presented astronomers with a tantalizing puzzle as it passed near Mars. Telescopes detected the faint but unmistakable signatures iron-nickel in its coma, a feature not commonly seen in solar system comets. The most plausible theory, 3I/Atlas, is a rocky comet with a higher concentration of metallic materials. Those metals were vaporized by the sun's warmth as it journeyed through our cosmic neighborhood. This visitor from another star challenges our simple classifications of celestial bodies. The scientific process will proceed: publications, open methods, independent checks, and competing models. As 3I/Atlas recedes, new observations will test whether solar heating drove the metallic signals. The universe is more diverse than we imagined, and each visitor is a clue. Now that we know what to look for, what elemental secrets will the next visitor reveal?